Hello everyone, and welcome to our video on the mechanism for making imines and enamines. This video will focus on the mechanism, so hopefully you've already reviewed what the reaction products will be. So make sure you check that out first. So when learning about these reactions, you've hopefully already learned that the reactions with amines can work for both aldehydes and ketones. In this video, we're going to focus on the ketone version of the reaction, but it does work with aldehydes, and just aldehydes you have to be a little bit more careful about the stereochemistry and things like that. So as you hopefully already know, the reactions with amines, it depends on if the amine is primary or secondary. So if you look here at the top, we have a primary amine, right? And primary amine because there's one set of carbons on that nitrogen. And then on the bottom, we have a secondary amine because there's two carbons on the nitrogen, right? So we said with a primary amine, you're going to get an imine product. So the imine product looks like a carbonyl with a nitrogen. So it looks like this. And then you've got the carbon group still attached. With an enamine, it's a little bit different. You still have where the carbonyl was, this piece. Then you're going to add the nitrogen where the double bond O was, but just a single bond. Then you'll add the carbon groups. And then the double bond is going to be on the carbons and not between the carbon and nitrogen. So that's a little bit different. And it goes on the most substituted side because of thermodynamics, which we hopefully already talked about. So now that we've reviewed the products, let's talk about the mechanisms for these reactions. Before we get started with that, I do want to point out that the mechanisms for the imine and enamine formation are really similar to the acetal mechanism. So you may want to have your notes open to that so that you can see how similar they are. The steps are really similar. There's just like a little slight difference at the beginning. All right, so definitely check that out or have it handy just so you can compare. All right, so let's get started on the imine mechanism. So one thing that's good to know about the imine mechanism, as we said, it's similar to acetals, except for, first of all, the nitrogen's only going to add one time and not two times like the alcohol does in an acetal mechanism. And the other difference is that nitrogen is a strong nucleophile. So because it's a strong nucleophile, it can add and you don't have to make a better electrophile. So basically the very first step of both of these mechanisms today is going to be the nitrogen nucleophile is going to add directly to the carbonyl first. All right, so let's do that first. So that looks like this. All right, so then once we've done that, we get this product, right? So we have a minus charge and a positive charge. This is weird for an acidic mechanism, right? Acidic mechanisms usually only have positive charge. So this is an exception to the acidic mechanism rule of only have positive charges, okay? This is the only negative charge we're going to have. So then it makes sense that the very first step we're going to do is to get rid of that negative charge, which would not be stable in acidic conditions. So we're just going to go ahead and protonate that, and then we'll draw this product. All right, so now we have something that's very similar to a hemiacetal, except for it has a nitrogen, right? So now we're going to do the same steps we would normally do. So let's go ahead and make this not a leaving group, right? So to do that, we're going to take off a hydrogen. And then we're going to make this be a better leaving group so we can get rid of the oxygen and make water, right? So let's go ahead and add one proton to that. Great. All right, so then the next thing that we're going to do is draw the product. So that looks like this, right? And then now what can we do? Right, so the last step was we wanted to make a better leaving group. So this step is going to be, we're going to have the leaving group leave. So that's going to look like this. So we're going to draw this bond to leave. And then also we're going to have these electrons come down and fill in what would have been a carbocation, just like in the acetal mechanism. So bring the lone pair down to fill in that positive charge. Okay, so then the product's going to look like this. Where does the positive charge go? On the nitrogen, right? And then we're almost to our product. What's the very last step? Right, we just want to take away the H. So that's going to be just removing H+, which you can show with one arrow for my class. And then you've got your product. So that's all you have to do. So hopefully that makes sense. Let me know if you have any questions. But that's the imine mechanism. So that's all you have to do. For the enamine, it's going to be very similar to this. There's just one extra step you do at the very end. So let's look at that next. All right, so as we said, the enamine mechanism is very similar to the imine mechanism. So I copied all the same differences from the acetal mechanism. The nitrogen nucleophile, it's only going to add one time. It is a strong nucleophile, so it's going to add first step, not have to make a better electrophile or anything like that. And then the last thing is it's going to have one negative charge in the acidic mechanism. Everything else will be positive. So what I want you to do is pause the video and try this mechanism out, looking at your previous notes from the imine. So it's going to be all the same steps except for the very last one. So maybe stop at the last step right before you get to the product, and then we can take it from there. All right? Okay, so pause the video and do that. Okay, so hopefully you've now drawn the whole mechanism. Does it look like this? Stop and check your work. Pause the video. All right, so now the next thing we're going to do is talk about the last step. So as you can see, we still have a nitrogen charge, right? A positive on the nitrogen. Before we had a hydrogen, so we could just remove that hydrogen and go to the product. But in this case, we don't have a hydrogen to remove to get rid of that positive charge on the nitrogen. So that's why the product's going to be a little bit different. So what we're going to do instead is remove a hydrogen down here on the carbons to make a double bond. So it looks like this. Draw out this hydrogen, that's the one we're taking away, and then draw it from the bond to the bond to make a double bond, and then draw an arrow from the double bond to the nitrogen with the positive charge to fill in that charge. All right, and then that's your final step. So you still only have the same number of steps, it's just a slightly different step at the end. And notice I'm calling this step something different. I'm calling it remove hydrogen to make the carbon-carbon double bond, just to remind me that I'm trying to make a carbon-carbon double bond, and that's what's different about the enamine mechanism versus the imine mechanism. One more thing I'll mention, this last thing at the bottom, the intermediate right before the product, is actually called an amine ion because it looks like an imine. So sometimes you'll hear people talk about the amine ion in a reaction or something like that. So I just wanted you to be aware that that's what it's called. All right, so now we've done both mechanisms. Hopefully they make sense. Try them again, practice them. And as always, let me know if you have any questions. And with that, we've reached the end of our video. As always, you want to check Blackboard or your LMS for the activities for this section, and let me know if you have any questions. I hope you have a great day. Thank you. Bye.